Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Well, I'm really pleased today to be introducing Chris Callison-Birch, who is coming to us from Johns Hopkins, where he's let me see if I get this straight, an assistant research professor in the speech and language.
Yeah, language Center for Language and Speech.
Center for Language and Speech Processing. So I think Chris's interests, overlap hugely with what's going on in our group. I think there's something in his agenda for everyone here. And I think more than anything else, I just love the problems he picks to work on, and he's done a lot of pioneering work in areas that I think we're very keen on: syntactic influence in machine translation, paraphrasing. He's also done a lot of really interesting work recently, it sounds like, with Mechanical Turk and trying to crowdsource data on Mechanical Turk for translation and other tasks. And without further ado, I will introduce him.
Okay, so please indulge me because I have a couple of self-introductory slides that I just want to practice. So I graduated from Stanford in June of 2000, and there I worked on syntactic models in the HPSG tradition. So I did my undergraduate thesis with Ivan Sag. Shortly after that, I decided to go to work at a company, and Bob was actually trying to recruit me to come to MSR to basically do a year-long internship on steroids, but that was the .com boom, so I got seduced into going to a .com, but busted not too long after that. But it was really exciting because it was a bunch of 20-somethings trying to scale machine translation to the web. So that sort of influenced how I thought about machine translation. And during my time there, I read Kevin Knight's Statistical Machine Translation tutorial workbook. And I got really excited because the company that I was working at was just packaging machine translation that other people had built. And I was saying, we could do this on our own. We could build our own statistical systems. And my bosses sort of poo-pooed the idea, so I quit and went to grad school. And while I was at grad school, I decided to start my own company to do just that. And so I started a small company during my PhD. So I was in the enviable position of being a PhD student with 2 full-time software engineers working for me, which was great. And we built a phrase-based statistical machine translation system, which at the time was pretty hard to come by. So a couple years in, I worked really hard to recruit Philip Cohn to come join the faculty at Edinburgh, including some smoky backroom deals with the head of the school to try to get student involvement in the hiring committee. And luckily, my efforts, Philip's talent, paid off, and he joined the faculty at Edinburgh. So suddenly it went from just me and my 2 software engineers working on statistical machine translation to a much larger and more flourishing group. And so when Philip was there, I helped him to write his first grant, which was this big EU thing called the Euromatrix project. And that spawned a lot of other collaborations as well. So we co-taught a class together at Estley, and we started doing this workshop on machine translation together. And in 2006, we did a Johns Hopkins summer workshop where we built this open source decoder called Moses that's pretty popular. And then during grad school, I did the necessary thing of publishing a lot of papers. At the end of the Johns Hopkins summer workshop, David Urowski came up to me and said, when are you finishing, and you should come here. So I did. I got this research faculty position at Hopkins, which is just a soft money position. So one of my major things to do at Hopkins is raise a lot of money to support myself and build my own research lab. So I did that, and I got a ton of research funding, and now I have this big war chest of about $2 million worth of research income over the past 2 years, and that's enough to support a small army of grad students. And so we built our own open source decoder called Joshua, which is a successor to Moses, which I'll be talking about more today. And I've continued to do the WMT stuff. And with my small army of grad students, I now have my own paper factory. And in addition to that, I've started to decide that I want to take over all of computational linguistics. So I got myself appointed or elected to the AMPTA executive, the NACL executive, the editorial board of computational linguistics, and help start the special interest group in machine translation. So I figure in the next 5 years, I'll have totally taken over computational linguistics. So there's my braggy introduction. You can give me feedback on it afterwards. So today I'm going to talk about research that I did this past summer. So this was a 2-month project that I did with a bunch of other researchers. And the topic for the project is this syntax bet that we have running in our subfield. So there's really been a reasonably long-standing debate about whether linguistic information can actually help statistical machine translation. And I think people fall into one of two camps. So the first camp is kind of typified by Kevin Knight and Daniel Marcoux, who really believe that syntax will improve translation. And they basically invested all of the efforts of their research lab and their company over the past 10 years to build all the machinery that you need to properly integrate syntactic information into translation. And then there's another crowd that's sort of exemplified by Franz Aack, who think simpler data-driven models are always going to beat the linguistically informed models. And the analogy that they draw is to n-gram language modeling, where by having tons and tons of data, you're able to better estimate your parameters, and the simpler models just do better. And that, of course, is a much nicer way of putting this point that Fred Jelinek, who's my current boss, has said infamously that every time he fires a linguist, his performance goes up. So I fall into the first of those two camps, and I actually believe that syntactic information must be relevant for translation, right? It's clear, it must work. So the talk that I'm going to give today is really my first foray into applying syntax to the problem of translation. So as I said, these are results from this summer workshop. So we've got a new center at Hopkins called the Human Language Technology Center of Excellence, which is a government-sponsored center that kind of does half classified research and half unclassified research. And they've started a summer workshop program modeled after the CLSP summer workshop program, where they bring a large group of researchers together for a 2-month period to really tackle a problem. So this work is done in collaboration with 19 other researchers, and we were all grappling with how do we improve the quality of Urdu to English translation. So we were all taking basically different angles on this, and the thing that I really tried was to integrate syntax into our models. And it worked well, and in fact it worked very, very well. So rather than hold my results to the end, I'm just going to give my punchline up front. So at the start of the summer, the Bleu score for our decoder, our Joshua decoder, was 25 Bleu points on this blind NIST-administered Urdu to English test set from this year. And at the end of the summer, we had improved a full 6 Bleu points, which is the largest single improvement in Bleu that I've ever gotten in my entire career. And just for comparison, that 6-point Bleu score improvement put us in second place, probably statistically insignificantly different from the leader on this blind test set. And you can see the field here for all of the systems that was submitted to NIST is really striking. So we've got this long mid-range here of people sort of in the low mid-20s, and you can see our baseline system was actually pretty competitive. And then suddenly we have this big jump, right? And so this was our final system, and this was the ISI syntactic system. So here's an example of the actual translations improvements that we got. So on the left hand there is our baseline system, and on the right hand is our final system. And you can see that our baseline system is getting the syntax mangled. So it's sticking the verb in the Urdu position, which is at the end. And in comparison, our final system at the end of the scale workshop is actually putting it in the correct order. So another thing that you can notice is that we're also handling all these out-of-vocabulary items, which were previously unable to translate, and we're now making a much better guess at it. So we get Los Alamos National Laboratory instead of Los Untranslatable Urdu Word National Laboratory. The other nice thing is the syntactic information actually allows us to better understand the output. So really what we would like to know when we're using this, or what an intelligence analyst would like to know when he or she is reading the output of this, is things like who did what to whom. So I've cherry-picked a couple of examples here where our baseline system, it's not really clear what's happening in this, and the final system it is. So in the first sentence, he said that China, North Korea, Iran, Syria, Pakistan, through Egypt, Libya, and Yemen is to provide nuclear technology. It's not really clear who's providing the technology to whom. But in our final one, because we've added this syntactic information, we get it much clearer. So he said that China would provide the nuclear technology to all of those other countries. And in this example, our baseline system is getting the relation wrong. So when asked why China was going to provide the nuclear technology, he said that China and India were the joint enemies of Pakistan. But that's not right. It should be China and Pakistan are the joint enemies of India, is the sentiment that was supposed to be expressed. And we don't get it exactly right, but at least we don't get it exactly wrong, like in our baseline system. So how did we get the improvements? So by far, the single biggest improvement came from incorporating syntactic information into our models. So we went from a hierarchical phrase-based model to a syntactically informed model, and that was the single biggest improvement of that 6 Blue point gain that we got. We did a number of other kind of interesting things that got us modest improvements that don't really have the same bragging rights, but I'm still going to talk about them because they're pretty cool. So the theme of our summer workshop somehow got determined to be semantically informed machine translation, where I was really just pushing for syntactically informed machine translation. So I had to make a nod in that direction. So we took semantic entities like named entities and modalities, which Bonnie Dorr is really big on, and incorporated those into our syntactic model by grafting them onto trees. And I'll show you pictures of that later. And the other thing I'll show off is our transliteration system, which is quite simple in that it just reuses all of the mechanisms that we use for translation to get it. But we also did some interesting things with how we got the data using Mechanical Turk. So I'll show you some numbers there. We did a bunch of other things like incorporating a lot of additional feature functions and improving the word alignments by taking the output of multiple word aligners and using a syntactic word aligner, but I'm not going to talk about those now. We've got a pretty comprehensive tech report which you can get and download from my webpage if you're interested in reading more about those things. So the system that we used, or that I used, we used multiple decoders in the workshop, but the one that I used was this Joshua decoder, which we're developing in my research lab at Hopkins. So the Joshua decoder was initially just a re-implementation of David Chang's Hiero system, but we've since generalized it so that it can use arbitrary synchronous context-free grammars. So I really am a big fan of using these synchronous context-free grammars as the underlying formalism for statistical machine translation, because I think they're a really theoretically well-grounded way of describing the problem of translation. So basically what you're doing is you're extending a context-free grammar. So instead of generating a string in one language, you're generating a pair of connected strings. So instead of one right-hand side, you have two right-hand sides, and I'll show a picture in just a second. And then you can specify a different ordering for the non-terminal symbols on the two right-hand sides. And that's great because it allows you to really, it provides you a mechanism to describe the reordering that occurs across languages when you're translating. And so basically the way that we translate is by parsing. So we have a synchronous context-free grammar here. So If you just ignored this side, then you would just have a context-free grammar. And so in order for it to be synchronous, you have a second side, and then you basically specify a link between the non-terminals on the two right-hand sides. So the only requirement is you have to have identical non-terminals on the two right-hand sides, but they can come in different orders. So you can see here that in Urdu, we've got a postpositional phrase for the PP, and the corresponding one in English specifies a prepositional phrase. So then the way that we translate is to have some Urdu input sentence, which I've romanized here just to make it a little easier to read. And then we apply all of our pre-terminal symbols. And once we've done that, then initially we have some English output or a space of English outputs that are in the Urdu word order. So we have initially Hamid Ansari, vice president for nominated was. So Urdu is a subject, object, verb language, whereas English is subject, verb, object. And then once we apply the higher level rules, then we start to get some of the reordering happening. So you can see here that by applying that PP rule, I reordered the Urdu postpositional into the English prepositional phrase. And by handling the verb auxiliary transformation, I reordered the positions of those two things. And then finally, by applying this VP rule, I've reordered the verb and the object in the two sentences. And then once we are able to reach the S symbol, then that's our goal symbol, and we take the derivation that has the highest probability. And here I'm just showing this toy example where there's only one possible derivation, but in practice we've got thousands and thousands of them that encode alternative translations and alternative orderings. And once we've reached that, then we've got a pretty good approximation of the English word order. So this is old hat for all of you. So for statistical machine translation, we don't write the rules. That's not done. So that toy example that I had, which was handcrafted, is not really how it works. So what we do is we take a bilingual parallel corpus and we automatically word align it, and then we extract our grammar rules from that. And the most common type of synchronous grammar that people extract is this hierarchical phrase-based system, which was invented by David Chang, and is basically the thing that sort of repopularized these synchronous grammars for the problem of statistical machine translation. So to call them a synchronous grammar sometimes is, causes dissonance among the linguists who are working for us, because they're really not what you would expect a grammar to look like. So the Hiero-style rules only have this single non-terminal symbol x, or rather two, an x and an s goal symbol. And then all of the rules look like x goes to something, x something, right? So you can use all of the mechanisms that you would use to decode a synchronous grammar under the Hiero system. So under a linguistically motivated system. So the Hiero system gets to reuse all the same architecture, but it doesn't have the same descriptive power as our linguistically informed one. And I don't think that it actually captures the reordering as well in Urdu as our syntactically motivated one. So you can see that for this Chinese example, you are capturing some of the reordering. So the relative position of x2 and x3 in this example are swapped between the Chinese and English. So you are actually able to get some amount of reordering under these Hiero-style SCFGs, but maybe not what we really want. So the way that we derive the Hiero systems is just to take sentence pairs out of our bilingual sentence-aligned parallel corpus, which we've applied a word aligner like Giza or the Berkeley aligner to, and then we have this automatic word alignment between the things. And then we extract phrase pairs in the same way that we did under the phrase-based statistical machine translation system, but we're now writing them as grammar rules. So we have x goes to this phrase pair, x goes to this phrase pair, and x goes to this phrase pair. And then for the smaller phrase pairs within the larger ones, you can simply plug in a placeholder variable. So you get x goes to some Chinese character x1, some Chinese character x2, and then have x2 with X1. And that's why it's a hierarchical phrase-based system, because you have phrases embedded within phrases. So in order to do, and then you can enumerate all these phrases, and then once you've done that over the entire parallel corpus, then you do counting and you estimate probabilities, and your rules all have a probability attached with them, which helps guide the search over the space of possible translations. So when we shifted to these syntactic rules, what we've done is we've just gone ahead and we've parsed the English side of our parallel corpus. So for all of the English sentences in our bilingual parallel corpus, we now have an automatic parse tree associated with it. So now when we pull out a phrase, we can give it a syntactically informed label. So we can say that this Chinese phrase corresponds to a verb phrase label because we pulled it out of the parse tree from the English sentence. So have diplomatic relations with North Korea is labeled as a verb phrase in the English sentence, and we treat the Chinese as a verb phrase just by projecting over these word alignments. And similarly, for a larger phrase like the few countries that have relations with North Korea, then we label that as a noun phrase. So the one kind of tricky thing that comes into play is what happens when you get phrases like this, the few countries that, or Australia is, which are not constituents according to our linguistic parse. So we're borrowing ideas developed at CMU, which just suggested that we give these a label by using CCG style notation, right? So we're now declaring the few countries that to be a noun phrase missing a verb phrase to its right, and Australia is a sentence just missing a noun phrase to its right. And the great thing about this is we can now go through and assign everything that we previously were able to extract under the Hiero system a syntactic label using the CCG style notation where you say it's a constituent phrase missing something else. And there's nothing special about these. I mean, these are non-atomic things, but we're just treating them as single non-terminals and directly reusing all of the mechanisms that we use when we're normally parsing the synchronous context-free grammars.
Chris, does that mean you have to have, in CCG you only have like 2 rules of combination or something like that. Yeah. Does that mean you have to have a lot more rules of combination to pick up all the CCG type fragments?
Yeah, so we've now ballooned the number of non-terminal symbols in our grammar from the Penn tree bank sized thing, which is on the order of like 100, less than 100. And now we're suddenly allowing these slash notations, which can be slash to the right or to the left. And we've also added concatenative things where we say this is a JJ plus an N. And so the number of non-terminals that we're dealing with now is on the order of like 11,000. So we've vastly increased the space of non-terminals in our grammar, which means that our models are much, much bigger, and the search space is much larger. So I basically exhausted the computing power that I had available over the summer. So we had we had one machine with 32 gigs of RAM, and by the end of the summer, that was the only machine that I could use to run my experiments. So rather than improve my models and my code's efficiency, I just got a big grant from DARPA, which allowed me to buy 7 machines, each with 128 gigs of RAM and 24 cores. So I'm just allowing the other Moore's law to help me out there. So our new training paradigm is this. So we still have our word-aligned bilingual parallel corpus, and now we've just parsed it. The nice thing is we've only parsed the English side. So that's great because we don't currently have a high-quality Urdu parser. And it also means that this method is likely to be transferable to other low-resource languages. So it'll specifically help when we're translating between a low-resource and a high-resource language, but not really when we're translating between 2 low-resource languages. But we'll take what we can get for now. And the nice thing about doing this is we've now allowed us to extract these synchronous context-free grammar rules with syntactic non-terminals, and that makes us feel much happier inside. And all of the non-constituent phrases that we were able to extract under the phrase-based models or the hierarchical phrase-based models are still extractable. And I think that this is actually one of the reasons that sometimes people have a hard time making claims about whether syntactic systems are better or worse than non-syntactic systems is that you suddenly get a coverage mismatch when you shift from the n-gram-based, phrase-based models to actually syntactic models. And usually your coverage is significantly reduced. But by adopting the CCG style notation, our coverage is identical.
So Chris, while you can still extract everything that you possibly could with the Hyro model, it doesn't necessarily mean you can assemble them together at runtime anymore, right? Because Hyro is very promiscuous about what non-terminals go together.
That's right. So I've got a node in here that's mislabeled. I'm calling this goal, but really it should be glue. So
you have a glue.
we basically will punt if we're not able to actually stick things together, and we do glue things together promiscuously in the same way that Hyro does. But the vast majority of our trees are actually pretty well structured. So the red tree on the left here shows the syntactically informed model, and the yellow tree on the right here shows the Hyro model. And you can see that we're getting a lot of what we hoped. So the PP rule here, this is for the same sentence that I constructed the toy example for. You can see that we're getting PP goes to 4 NP. So we're actually anchoring all of our rules with a terminal symbol. So in the toy example, it would be PP goes to P NP, but here we're forcing at least one terminal to appear in every rule, which is part of the reason that we end up punting and backing off to this goal rule, or this glue rule. So we've got PP goes to 4 NP, and on the Urdu side, we have the corresponding Urdu postpositional here that's following the noun phrase. And similarly, for the VP, we've got VP goes to nominated PP, and on the Urdu, we have VP goes to PP followed by the corresponding Urdu word. And that's allowing us to get a much higher quality translation than on the Hyros tree, which just doesn't really have the same guidance for how you restructure the Urdu.
One more interjection. So Hyro only allows glue rules that occur without reordering.
Yep.
Do you have anything to address that? I mean, especially in verb final languages, you may often need to fall back to a glue rule, especially with longer predicates. You may not be able to get that verb back into second position.
Yeah, so we don't yet. So this is pretty preliminary. I haven't yet published this. One obvious thing is the CCG style rules where you're saying this is an NP missing a determiner to its left. If you have a NP missing a determiner to its left and a determiner, you should be able to get an NP by sticking those together. But we don't actually insert those rules because we've still required that every rule be a lexical anchor. So we, in that situation, punt and go to the glue rule, but that's completely wrong-headed. Really, we should have a set of glue rules that actually do that forward application or backward application that you have in CCG. But currently we're not. So, I mean, really we're kind of doing this blindly. We're just saying, extract this grammar, pretend like it's any other synchronous context-free grammar, and go. So there are lots of tweaks that we could do to this, or really logically motivated improvements that we could do to this that we haven't yet done. So I think that, yeah, there's a lot of space to explore still.
Just for reference, my original question was motivated by the assumption that you'd have those rules,
yeah,
and that they would all be particularized to the non-terminals, the blown-up set of non-terminals.
Yeah. So I misunderstood your question, and no. And so the number of non-terminals will stay fixed, but the number of rules, once we've done that, will expand.
That was
Yeah.
the expansion I was asking about.
So now I'm pivoting from the syntax into the semantics, which ostensibly our workshop was about. So due to various reasons, the workshop was called Semantically Informed Machine Translation, which I thought was crazy and would never work, because I'm only allowed to believe in the next incremental thing. But I had to eat my hat because we actually got some semantics to actually improve the quality of translation, which really surprised me. So the way that we integrated semantics was to take these high information value elements, which are heinously abbreviated to beehives, because that's what they were really giving me all summer long. And in particular, we were basically taking things that are output by a tagger, like named entities or modalities. And so the trick that we did to actually integrate these into our system to allow me to reuse all of my machinery was just to graft these onto the syntax tree. So Scott Miller from BBN was on our team, and this is a trick that he's used before, and he suggested this, and it ended up working pretty well. So now we've got an English side of one of our sentence pairs. With our parse tree, we run our named entity tagger over it that tells us that Lebanon is a geopolitical entity, as is Palestinian Authority, and missiles are a type of weapon. And then we've just gone through and grafted those named entity tags onto the trees. And so now our non-terminal symbols are again expanded because we now not only have a generic NP type, we also have an NP geopolitical entity, we have an NP weapon, we have an NP person, we have an NP location. So that expands the number of non-terminals that we're dealing with even more, but luckily we have all that RAM from all those machines from DARPA, so we don't have to worry about that. And so a neat side effect of this is as we're translating, we actually get kind of a weak Urdu named entity tagger coming out of it. So this is not how I recommend writing a named entity tagger at all, but for things that we've actually observed in the corpus, we get a nice side effect of having them labeled that way. So for Palestinian, we're labeling it as the adjectival form of a geopolitical entity. For West Bank, we're aware that that's a noun phrase, but also a location. For Hamas, we're aware that that's a noun phrase, but also an organization. So that gets marked both on the English side that we're generating and on the Urdu side, which we're parsing. And similarly, we were really interested in these modalities to tell whether something had actually happened, was something that was intended to happen, was something that was capable of happening. And so we got some amount of modality tagging as well. So on the left here, we see that we've got a verb phrase where the embedded verb is being negated. And on the right, we see that the embedded verb is something that indicates is able to happen. So it's a trigger, can as a trigger indicating that something is able, and the verb phrase is the target of that, capable.
What list of modality and named entities are you using? Is that from ACE?
So this is one that Bonnie Dorr and Laurie Levin adapted. So I don't know if they took exactly the set from ACE or if they had a refined set. I was pretty hands-off in terms of what they actually did to define these. I was trying to help them figure out how they could get the data properly annotated so we could try some sort of real statistical tagger for the modalities, but in the end they just had basically a list of words that they were interested in and wrote something using the Stanford tree surgeon to go through and mark up all of our English stuff with their modal tags on top of it. But if you're interested in exactly the set, then it's described in one of the chapters in the final report, which you can grab from my webpage. So in the end, we got a small, but probably significant improvement in translation quality by integrating these hives onto our syntax trees. So adding both the named entities and the modality had an additive effect, and we ended up getting about a half Bleu score improvement. So usually that's not something to write home about, but aside from adding the syntactic information, this was equal in size to any other improvement that we got. So half a Bleu point here and there adds up pretty well. So the reason I think that this is working is because the named entities are allowing us a way of better capturing the distributional properties of the different named entities that we're marking. So, places are going to have a different distributional signature than people. And so by refining our generic NP tag to add these refined categories, we're better capturing that distribution and capturing the reordering better. And similarly for the modalities, I think we're adding better structure to our verb phrases. So the verb phrases in the tree bank aren't all that well structured when you've got lots of auxiliaries on top of it. And here, I think what we're really doing is adding auxiliary structure.
I had a question also. The baseline syntax system already has your syntax that you explained, right?
Yeah.
And in earlier, so your file system had 31, and you said most of the improvements came from syntax.
Yeah.
Whereas everybody else was like 25. So here, why is the system?
Oh, sorry. So this test set is not the same test set that we're using. So the one that I showed at the start was the blind test set that we didn't have the answers to during the summer workshop. This was an internal test set which we had the answers to so we could evaluate on. So this was basically our dev test set. Yeah, sorry. I should have made that clear. I've got a breakdown of all the improvements that we had on our dev test set. I'll show you in a couple slides. So the other improvement that we had in addition to syntax and semantics that I was involved with was trying to do transliteration. So transliteration is really important when we're dealing with...
Just thought of Arabic, it's right to left.
Yeah. This is not as bad as it actually looks. It just looks cooler this way. Yeah, so as Bob says, the Urdu is written in the Arabic script, which is right to left. So we're treating transliteration as a statistical MT task, but it's actually a little bit easier because it's just a monotonic task. We don't have to do any reordering.
So, in that example, you had at least one did you have one crossing the line?
The X.
So I think the X
Yeah.
just goes to two
Phonetically.
symbols.
Yes, little consonant.
Oh, okay. I'm
It's not-
just having trouble.
Yeah, I should have just read
I made a right turn at Albuquerque. That was
So the mechanism by which we're doing this is not complicated at all. We're just reusing the same machinery that we had before, using our decoder to explore the possible search space. So what we've done is we're just treating transliteration as translation, but instead of aligning words across pairs of sentences, we're now aligning characters across pairs of names. And the rules that we learn are now just sequences of letters that transform onto sequences of English letters. And so the language model is just an n-graph letter sequence language model built off of a big list of English names that we get by running our English named entity tagger over the whole of the gigaword and pulling out all the names there, generating statistics over what are likely character sequences for names. And so the requirements for doing this is just that we have a large list of paired Urdu-English transliterated names, that we have all these names that we gathered from the gigaword to have our character-based language model. And then the one slightly tricky thing is when we want to integrate these transliterated things into our decoder, we now have to have an appropriate syntactical label because these words are now going to have a non-terminal to allow them to fit into all of our syntactic rules. So we should have, this is an NP person, or this is an NP location. So yeah, the way that we did that was just to take the K most likely label for every named entity that we found in the bilingual parallel corpus, and then assign every one of our unknown Urdu words that set of possible syntactic labels. So NP person was probably the most likely, but we also allowed others. So we gathered the training data in a variety of ways. So we extracted name pairs from our parallel corpus. So we just ran our English named entity tagger over the entire parallel corpus. We looked at what corresponding Urdu words were aligned to those English names. And there we gathered a small set of names that we could use to train our transliteration model. We augmented that initially small set of word pairs by gathering training data from Wikipedia. So I took the English Wikipedia and I looked for articles in the category person born in, and I just went through all years and gathered all English articles about people, and then looked for the subset of those that had interlanguage links into Urdu, and then used that article title as a set of additional labels. So we got about 900 additional name pairs from that. And then one thing that I suggested that we started doing with a remarkable amount of success was to use Amazon's Mechanical Turk which is an online market for work where you can post any human intelligence task to have the crowdsourcing masses out there just do it for you. And so we tried posting Urdu in it, and we got a lot of Urdu speakers to do this task for us. So we posted about 5,000 English names and about 5,000 Urdu names, and implanted some that we had a known transliteration for. And we also had an informant, linguistic informant, that was available to us to vet these things. And in the end, about 2/3 of the data that we were getting back was actually high quality, usable data. So in the end, we gathered an additional 12,000 labels or named pairs for less than $300, which I thought was awesome. So I've got this little learning curve here that shows how good our quality is as we add more and more money. So here's the average edit distance. So from the reference name for a known pair that we have, so lower is better. This blue line here is the transliteration system that's distributed with the LDC language pack. The green line here is what you would get if you just trained off of the Wikipedia articles. And then the curve is as we're adding more and more data as the summer went along.
That last $51 was not.
Yeah. So this was a bad investment. I think that actually that was a set of cheaters. So the way that we would vet these, in addition to having a spot check by our informant, was we redundantly posted the data to Turkers. So whenever we got agreement among the Turkers, we would say, oh, that must be a good label. But for these, like 100% agreement, which I think meant that just someone had 3 different accounts and they were tossing all identical answers. So as a result, I ended up adapting the way that we're formatting this. So I actually stuck in a little web bug so I could get the person's IP address and their like geotagged location. So I could detect when someone was coming from the same IP address and filter for that. But it was also nice because now I have a way of seeing, oh yeah, look, all of these people doing this Urdu task are from Pakistan or India. And that gives me a much higher confidence that the labels that I'm getting are from someone who's likely to understand the language.
So this is based on the 2/3 of the data that you did good?
Yeah, I think that this is keeping only the good labels.
Did you try using all of it? Like, I was just curious how much that,
Yeah.
size versus cleanliness.
Yeah, I'm not sure if we actually ever included the labels that there was disagreement on. And in fact, that would actually probably be a good thing to do because there is a natural amount of variation that you get in transliteration, right? Like there's not a single canonical transliteration for every name. So I bet that even if you had some variance, it would be fine. So I think that the thing that would be best to do would be to set some threshold edit distance and discard things that are way beyond that, but keep things that are in the right ballpark. Yeah, I think it'd be great. My student, Annie Irvin, who's a second-year PhD student at Hopkins, was the one running these experiments. She was great. She did most of this with very minimal guidance from me. But she's got a ACL submission now looking at transliteration between like ton of languages because we did the same trick for the Wikipedia interlanguage links for all of the languages within Wikipedia. So we have this big matrix of language X to language Y transliteration pairs.
Japanese, English, using Wikipedia data. Just Wikipedia, we have 56K.
Yeah.
But only about probably 40K is clean.
Yeah.
So that's why I asked this question.
Yeah. So it's not perfect, but I mean, for most languages, we're hitting an average edit distance of like 1 letter from the reference. So I think that, I mean, I'm pretty much willing to say, yeah, that's good enough. But it really depends on how much data that we've got. Well, we just treat we break off a chunk of the Wikipedia names that we've gathered and treat that as a reference. So, we do an n-fold cross-validation for the smaller data sets. Oh yeah, and so here's an example of what those names correspond to as we're doing it. So each column shows, as we increase the amount of data, how the things transform, and the bottom row here is our reference one. So you can see when we're training only on like 84 examples, they're pretty garbled. So we get who as the initial suggestion for Yahoo, and then we get Yahoo, Yahoo, Yahoo. We never quite hit it, but it's at least pretty understandable. And for a lot of them, we're getting it pretty close. So here's a breakdown of all the Bleu score improvements that we got. So this last column is the one that we got for transliteration. So it's only a half Bleu point improvement for adding in the transliteration versus chucking out the Urdu names untranslated. But I think that's actually an underestimate of how good the translation quality actually is, because Bleu is penalizing us if we're within a few characters edit distance. So another vein of the research that some people did over the summer was a project that Bonnie Dorr was in charge of on actually having an appropriate automatic evaluation measure for things like this that took edit distance into account and gave you some amount if you're close. So that's the breakdown of improvements. You see the biggest improvement is here, which is where we added the syntax, and then we got this additional half point by adding the semantic entities. We got some additional tricks like using word alignments from a variety of aligners, doing minimum Bayes risk decoding instead of just taking the single maximum probability one, and then adding in the transliteration. So, yeah.
How much training data did you have for Urdu-English? It's like a million words?
Yeah, that's my next slide. No, that's great. So why did this work? So, I mean, the awesome thing about this is that the syntactic translation models got us a nice gain, right? It's great. It's really what we think intuitively should work, and it's nice to finally be vindicated for once and have a very, very clear case of where it works. And previous work has always kind of like shown maybe some improvements, but maybe not. But here it was extremely clear-cut. And I think the reason for that is that Urdu is really the ideal language to be dealing with to show off the quality of your translator or of your syntactic translation models. And the reasons for that are the one that Chris was just highlighting. Firstly, we only have a very, very small amount of data. So for Urdu, we only have 1.5 million words worth of parallel text. So we're dealing with a very low resource language. And secondly, its word order is very different than English, right? I mean, it's verb final, it's postpositional. Like all these things that you can describe using linguistic words are exhibited in the Urdu, and you have to get those transformation rights. So really, we can't do the strategy of just memorizing sequences of phrases, which we could pretty much get away with for Spanish English or for French English, even for Arabic English, once we scale to enough Arabic. And we really have to have a better strategy for generalizing. So I think that's the answer. So here's an illustration of the size of the training data. So for Urdu, we've got 26 times as much for the European Parliament corpus. We've got over 150 times the amount of data in the GALE project. I built a really big French-English parallel corpus by crawling everything I could possibly find, which is 500 times the size of our Urdu.
So Urdu is basically Hindi written in Arabic scripts, right? Has anybody tried writing Hindi in Arabic scripts and considering it as an
So that's a very, very good suggestion, and that's something that we had on the agenda over the summer that David Urowski was really pushing for that we didn't end up getting to. But I think using a related language, and in the case of Hindi, an extremely related language, you would imagine that you could get more. So,
conditional education might help. It might not help with Portuguese or Spanish, but
yeah. So far I haven't found such a large Hindi-English parallel corpus, but I'm building one using Mechanical Turk, so, and it's going really well, and I think it should be good. So this is a little chart that I put together that's an informal survey. So this pie chart here represents the distribution of these different word orders for languages according to the World Atlas of Language Structures. So if you don't know about WALS, WALS.info, it's an awesome site with a rich inventory of descriptions of languages. So you can just generate things like that. And then this is just by language. So yeah. And so then you can compare that to like, yeah. You Microsoft guys are all like that. And so then we can compare it to like the types the word orders of the languages that are commonly written about in the statistical machine translation literature. And in particular, these SOV languages are really underrepresented and the SVO languages are really overrepresented. So of course we're not showing improvements. Like, I've forgotten where I put Chinese.
I mean, it's SVO, but it has some postpositional things
Yeah.
in it.
Yeah, I put it wherever Wallace puts it, so we can reverse engineer it.
Channeling Francois, and maybe this is on your next slide, but you started out framing this in terms of the syntactically informed versus simpler model plus lots of data. But can you really conclude anything from the Urdu experience about that debate? Because there just isn't enough data for these languages.
Yeah,
to really answer the question.
so the title of my slide is like the strongest claim that I'm willing to make at the moment, which is that syntactic models help us for low resource verb final languages. And really I need to do additional due diligence to show it for a variety of languages rather than just Urdu. But I think...
So, I mean, that test tube result, you can consider it a test tube result for Urdu that might fade into insignificance if you had 100 times as much data.
Sure, but I think the chances of getting that 100 times more data is...
Sure, but that's a different question from whether...
Yeah, so one of my next agenda items is to create a test suite of data. So I think I totally agree with I totally understand where you're coming with from that criticism. And I think it's a common one, right? Like people will say, yes, but, right? So it's really, culturally, it's hard to publish a paper where you say, I took the Arabic and I threw away 99% of it, and hey, look, my model gets us better improvements. Like people just don't take you seriously. But the great thing about this is like there are lots of languages for which we don't have that much data. So it is the maximum amount of data that we have available. So I think my goal is to create a bunch of training data using Mechanical Turk for a variety of verb final languages, and hopefully that'll be, yeah. Well, resource force for us.
Does Google have Urdu-English?
They don't. So
Because that's too bad,
yeah.
because that would have been your comparator.
Well,
because
except
they
that
presumably
they're
would have
scraping
the
web data
max.
and there's not much data, so...
But then their argument falls flat, right? Then the argument is exactly
I don't
what Chris
think
wants
so.
to hear.
So
There are no resources.
I think that Google doesn't have very much Urdu data. So I've got this project for using Mechanical Turk to create data for low resource languages. And so Google gave me and Miles Osborne $45,000 to investigate this, and they came up with a list of languages that presumably they don't have that much data for, that are all looking quite low resource, and Urdu was among those. I've been posting data for these low resource languages. For the Hindi, I get it done really, really fast. Like last week, I got 500,000 words worth of Hindi translated. Yeah. The Urdu goes at a very fast clip as well. The Farsi, Japanese, and Korean are coming in at a slow trickle because I've uniformly priced these. So I'm paying about 50 cents per word, regardless of what language, which ends up working like out to about 50 cents per hour, which I sometimes start feeling really guilty about. Yeah, right. So for some languages, I may have to pay much more than I'm currently paying. But I did this experiment for EMNLP last year where I looked at the quality of the Mechanical Turk things versus LDC translators. So there's this multiple Chinese translation corpus where they have 11 different human translations of varying quality. So you can do an experiment for the Chinese where you have an error bar by holding one of the translator's translations out and comparing it to the other 10 using Bleu. So that's the amount of variation that you get there. I took the first 50 sentences of that and translated into French, German, and Spanish. I had some of my grad students who are bilinguals do that. So the error bars are identical for those. The green is the Mechanical Turk. So you see for a lot of the languages, you're within the error bounds of what the professional LDC translators are getting.
Is this Bleu?
This is Bleu, sorry. And then the orange is a machine translation system. This is actually Babelfish rather than Google, because for Google I was getting like superhuman Bleu scores, like better quality than the LDC translators because I think they've trained on this data. For the Urdu, I have fewer references, so the scores are lower and the variance is tighter. But definitely, it seems to be that you can get some information that's not yet in a machine translation system from Mechanical Turk people, even if their quality is not super high.
What do you make of French being so much lower?
I personally think that that's probably like everyone who took high school French thinking that they speak French. Yeah. Here you also see like return rate difference. So the Spanish, I posted, I've forgotten, I guess 50 sentences, and I had 3 people do each of those 50 sentences, and the Spanish was done in like an hour and a half. The French took a day, the German took 2 days. The Chinese took a really long time, and I'm kind of suspicious about that it was actually done by Chinese speakers. I think it might have been done by people pasting into Google Translate. So I've since thwarted that by all of my Mechanical Turk translation hits now convert the text into images, so you can't just copy and paste into Google Translate, which is like cut the rate of that kind of cheating down to almost none. So it's really easy now to detect if I'm having someone cheating, especially for more exotic scripts like Arabic script or Chinese script. You have to have a really small group. You have a smaller population that can type that. So transcribing it and then pasting is harder. So I think that this is really looking promising. And I've got, 45K from Google and 20K from DARPA to do more exploratory research in this area. And I'm hoping that I can pull together at least test sets for really low resource languages. And optimistically, I can pull together some training sets and get to about the size that we have for the Urdu for an interesting set of languages that we can then write papers about and make stronger claims than I've got.
To say a low resource language, I mean, if it's that cheap to generate data, then what's to stop you from getting 20 or 30 million sentence pairs? How much would that get? How many, like $40, $50? How much would that cost?
Yeah, really, I just need a corporate sponsor, so. So I'll just whiz through these. There's only 2 or 3 slides left. So another agenda item is better grammar, right? So there's no reason to think that the Penn Tree Bank tag set is especially good for translation, and in fact, there are lots of reasons to think that it's not capturing the distinctions that you want to make. The refinement that we made to it with the semantic tags showed some promise, but I really think that that's probably not the correct way of doing it. I would really like to have my students work on automatically splitting the tags, kind of in the style that Slav and Dan did on their monolingual parsing work, and I think that that's super promising. I think now that we've got this in place and now that it's working reasonably well, we can borrow a lot of tricks from the monolingual parsing literature, so we can experiment with lexicalization and things like that. And I think there's a really interesting, rich set of things that we can be exploring to have a more refined grammar that's better for translation. And I'm really excited about that. I've got a master's student right now working on a systematic comparison of different kinds of grammar extractions for synchronous context-free grammars. So this is like in the style of the CMU work. There's also the Gale et al. GHKM stuff, which uses a different style of rules that you extract, and there's Hyro. And then there's all these different flags that you can set, right? So whether you force it to have a lexical anchor, where every SCFG rule has a terminal symbol, where you vary the length of the rules, and so on and so forth. So I'm hoping to more systematically explore that space and see what happens. And finally, I think you can put these ideas together. So we could try active learning for statistical machine translation. So you can basically have your model guide what sentences you have your Turkers translate. And I think that that's a really exciting area. And we started some work on that over the summer, and I think that it's really promising. One thing that we tried that seems to get you better value for money is not to have people translate entire sentences, but to just select phrases from within sentences and then have them translate that. And even using a very simple-minded thing like vocabulary growth, you can get a lot more relevant data a lot faster. So I think that there's really cool stuff to do there. One of the PhD students at Hopkins, Jifei Li, has a really nice semi-ring architecture for calculating second-order expectations over the parse chart that we're building, which is really, you can calculate things like the entropy of the different parts of the parses and expectations about length and all this. And I think you can really use that to do model-driven active learning very, very naturally. So I think that's on the agenda as well. Okay, last plug. This is free software. The Joshua decoder is open source and does everything you want. If you guys are averse to open source licenses, you can have it in whatever license you want. We're happy to give it out that way. It's really mainly just we want people to use it, so we're not dogmatic when it comes to the open source stuff. So if you're interested in experimenting with it, but the LGPL prevents you, then just let me know and we can figure out a way of getting it to you. Okay, that's it. Thank you very much.
With the transliteration, you only trained on names, but in fact, I noticed intelligence
Yep.
previously was in original script and Arabic script, and then came over.
Yeah, so we actually ended up training on, or we actually ended up coming up with 2 transliteration models, one for names and one for non-names, because there's a lot of borrowed words that you see in Urdu. So we have a second. We have two models, one that guesses that it's a name, which we can do with our rudimentary Urdu named entity tagger, which is not to say the Joshua system as a kind of weak named entity tagger. It's got to be something else, because if Joshua tags it as a named entity, then it will have seen it in the training data, and we don't really need to fall back to the transliteration module. So we also had a Urdu named entity tagger. So if we tagged it as a name, then we sent it to the name transliteration system. If we tagged it as anything other than a name, then we sent it to a second one that was trained on a superset of the name data. And we had a less clear way of choosing what things we should have transliterated. Like, how do we gather the data for non-name transliterations? I think it would be interesting to try to go through and classify all of the words that you could extract from the parallel corpus as transliterated or not, and then use that as evidence. But as far as posting data to Mechanical Turk to gather training data for the transliteration process, you have to assume in advance that it's going to be transliterated rather than translated. And it might be that you could target certain things like products or technology terms with reasonably high probability that it would be transliterated, but figuring out where to get that data is a little bit trickier. But it is the case that we did handle non-names, and we did find a benefit from having 2 separate things dealing with that.
So I think all this syntax stuff is great. I mean, it's a nice way to handle reordering. Right? Like, it's fundamentally where syntax is actually buying us something. It tells us a little bit about a constituent structure, and it gives us kind of this mobile on which we can rotate our constituents while we translate. And but the semantic stuff is actually kind of interesting, right? Like, I'm sort of with you. The word semantic is becoming rather ugly to me, what with all this semantic web and the semantic that. But here it actually seems like you're getting somewhere by throwing in some named entities. I mean, do you have plans to push that further? Like, the modality, in fact, I was kind of surprised by that. You throw in some modal tags and you get a little bit better, and it's additive with the named entities one, which is really nice. So what about more semantics? What about...
Yeah, so it's not the first thing on my agenda. I was really surprised that it worked, and I was really pleased because there was a large subset of the group that was working on this at the COE who really was pushing that, and I was really skeptical, and I had to eat humble pie in the end because it turned out that it did actually get us a modest gain, and I was really pleased by that.
Is that just a variant of class-based language modeling? Isn't it a similar kind of technique?
Yeah,
for sure. There's predefined classes, but you were suggesting that
The named entity would be class-based.
Yeah, that's what I mean.
But I would be surprised if a class-based language model would pick up on the modality stuff. I don't know.
Yeah.
But I think it's probably being handled. You've got negation.
Yeah, we've got negation, and we've got like
in a way that
auxiliary verbs better handled, right? So we've got could, should, would, and could have been versus been have, right? Like there's a very strict ordering on those.
As you were saying, the weaknesses in the Pentry Bank representation are being kind of supplemented by this. But if you had a different parse to begin with, you might consider that syntax rather than semantics. I mean, these things are arbitrary.
Yeah, I mean the thing that the reason I think it worked is because you're getting a better refined set of tags than you have as the starting point. But I think that there are other reasons to be interested in it, right? Like being able to flag sentences where you're talking about weapons, which is one of the named entity tags in our tag set, might be interested for the sponsor of this research, you know, or things like that. Or being able to talk about when something is a type of modal that is a belief instead of something that's an intention, like, or an ability versus, you know, a hypothesis or whatever. Like those are pretty nice fine-grained distinctions to be able to make if you're using this for intelligence purposes and you want to act on something.
So arguably, if you got the translation correct, that would simply be a process in the English.
Yeah, but I sort of feel like the direction I was trying to push the people working on modality for Urdu was don't worry about improving the translation quality using the modalities. Work on improving the Urdu modal analyzer. Even if we get the translation completely wrong, being able to say this statement is one of these modes, right, would be extremely valuable for some applications. And so the fact that it ended up refining the translations was great, but there's another reason for studying it, and I think that there's a really interesting vein of research there as well. So probably not going to be something that I make major contributions to, but I think it's a really good thing to be doing.
Kind of the ablation studies that you showed were on the set that you could look at.
Mm-hmm.
Did you do those same ablation studies on the blind test set?
No. So
because I mean, there you have a much larger gain from syntax. You have a much larger gain.
Yeah.
Overall, and so I'd be interested to know.
So the gain was roughly similar. So let me see if I can pull up that slide real quick. So we went from 23 to 28. So we got a 5-point spread here versus a 6-point on the other. So it's pretty much same ballpark. So I would expect it to be similarly behaved. We didn't do it because we just held that blind set blind for as long as possible, and then basically at the week 8 last couple of days, we said, okay, what's our best system? Let's send it off to Kay Peterson at NIST and have her score it for us. And she did it, and it came out well.
So in the first slide, you showed the best system.
Yeah.
So what type of system is that?
So that's, I'm not allowed to label it just due to the NIST restrictions, but that's from a certain university in Southern California. And so it's also a syntactic system. So they're using a different flavor of syntax. I'm not exactly sure which one they're using. So the thing that they seem to be interested right now are like synchronous tags and synchronous tigs, which I think they actually compiled down into SCFGs, but I'm not really sure. So one of the problems with that particular institution is that it's got a link to a company and all of the IP goes to that company. So, you know, my hippie open source heart is not with them on that part. On the syntax is great, but it's nice to have an open source syntactic system that anyone can mess around with, and because it's transparent, right? And yeah, one of my students is working on like a make command that'll download all of the data that we used for an experiment and rerun with the same parameters, so you can exactly rerun our experiments, which I think is also the right way to be going. Ted Peterson had a really nice last word in CL on empirical NLP is not empirical if you can't recreate the results, and I think that's true. Okay. All right, thanks again.